welcome to this video. I am POOJA VAISHNAV and in this video I am going to solve KCET 2023 previous year question paper. So before moving on to solve the questions, I want to tell you that this question paper is available in the link present in the description box, and the question paper code for this particular question paper is D4. So without making any delay, let's get started. So you can see first question on the board, that is the compounds P and R in the following reaction. So here they have given one of the reaction. We have to find P and R. Okay. So what is this? CH3CHO is what? It is a acetaldehyde in presence of CH3MgPr. What it is? It's a Grignard reagent, right? When we react CH3CHO, that is acetaldehyde with Grignard reagent, we know that we get alcohol, right? So what type of alcohol we are going to get? Here we are going to get a secondary alcohol. So P is going to be a secondary alcohol. So let's write that CH3, CHO we have. CHO is got converted into alcohols, that is OH, and here hydrogen. Okay, this is secondary alcohol. And then they have given concentrated H2SO4. When we put a secondary alcohol, when we react with the concentrated H2SO4, we know that here it is going to dehydration occurs. Removal of H2O is going to happen, right? So Q is going to be a alkene. When H2O is removed from the alcohol, we get alkene. So CH3, C, double bond, CH2. This is a alkene. We get alkene by the removal of water. So what is here this alkene when it reacted with B2H6 in presence of water and OH minus ion. So what it is? This is undergoing hydroboration oxidation reaction. So we know that in hydroboration oxidation reaction, it follows anti-Markovnikov rule. So what is anti-Markovnikov rule? The negative part, that is OH minus, is going to attack the carbon which is having higher number of hydrogen. So here we know that this is going to be, this carbon is having higher number of hydrogen. So this OH is going to attach here. Then R is going to be what? CH3, CH, single bond, CH2, OH. Right? And what it is? This is again an alcohol. This is again an alcohol. But what type of alcohol it is? It is primary alcohol, right? So this is a primary alcohol and P is secondary alcohol, and they both are secondary and primary alcohol are position isomer. So the correct answer here is option number C. So let's move on to the second question. Is option number C. So let's move on to the second question. Here we have a second question. Anything does not undergo. Here they have given options like Friedel-Crafts reaction. It does not undergo Friedel-Crafts reaction. And option number B they have given as bromination. Option number C, nitration. And D, sulfonation. Aniline does not undergo. Which of the following it does not undergo? Aniline forms benzene ring attached to NH2 group. This is aniline. We know that aniline does not undergo Friedel-Crafts reaction, but it can undergo bromination, nitration and sulfonation. But the reason you should know, right? Friedel-Crafts reaction, because this NH2 group, nitrogen has a lone pair of electron, it easily undergo protonation. This is the reason why it does not undergo produce Kraft reaction. So next we'll move on to the third question. The heating of phenyl methyl ketone, phenyl methyl ether with hydrogen iodide produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. A and B are. Here we have a third question. The heating of phenyl methyl ether with hydrogen iodide produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. We have to find out A and B. What is phenyl methyl ether? We will write on the phenyl methyl ether. Phenyl C6H5, methyl CH3, and ether has a O here. This is phenyl methyl ether, right? Which are treatment with hydrogen iodide. What we are going to get here? Here, when we react ether with hydrogen, we know that it undergo what? It undergo a substitution reaction. Here, this bond is going to break and hydrogen is going to add up here. We get C6H5 and OH. What is this? Phenol. We get phenol here. The A is here, phenol. And which on further treatment with concentrated nitric acid, HNO3. We know that when we react phenol with nitric acid, it undergo nitration. So the product is going to be, we know that whenever nitration occurs, all the hydrogen present over the benzene ring is got replaced by NO2. So the product is going to be like this. OH is already here, NO2. Ortho and para position are occupied by NO2. And what it is now? This is picric acid. Picric acid. Okay. So we got picric acid as B and phenol as A. So in the option you can see option number B is the correct answer. In that phenol picric acid is the correct answer. Next we will move on to the next question. Okay. They have given an equation like this. Phenol NaOH, then what is A here, and then CO2, and the second reagent is H plus, and then what is B here, and again we have CH3CO, acetic anhydride, okay, and Y. This is the major product. Okay. They have asked what is Y here. We have to find what is Y here. So we must solve what is A and what is B then, right? If we look into this question, this is phenol. When it reacted with sodium hydroxide, what we get? We get sodium phenate, right? This hydrogen is replaced. Sodium is going to be replaced. So what is going to be A? A is going to look like this. Okay. Then this sodium phenate when reacted with CO2 and H plus, what happens? We know that it is undergoing one of our neighbor reaction, that is coal-base reaction, right? So what we are going to get B here, we are going to get B as like this. Again, ONA is going to become OH and COH group here. What it is? Salicylic acid. We got B as salicylic acid. And again, now here we have acetic anhydride CH3CO twice O. What happens here? This H is got replaced and we get OCOCH3, and this is what it is now. It is aspirin. What it is? Aspirin. So in the option you can see they have given us 4 options like this. Option A, cumin. B, picric acid. C, salicylaldehyde. Option B, aspirin. Okay, so option number B is a correct. Option number D is a correct option here. Let's move on to the next question. Question number 5. Quick question. A better reagent to oxidize primary alcohol into aldehyde. A better reagent to oxidize primary alcohol into aldehyde. They have given A, B, C, D. Okay, we have to see the question first. Primary alcohol to aldehyde. We know that when we want to convert alcohol into aldehyde, what we need? Oxidizing agent for sure. Primary alcohol. Okay, this is primary alcohol. And if I want to convert into aldehyde, we need a oxidizing agent. What we need? We know that we have different oxidizing agents have different strength. Some are strong oxidizing agent, some are mild oxidizing agent. So whenever the alcohol is treated with mild oxidizing agents, we get aldehydes. But whenever we react alcohol with strong oxidizing agent, we react with strong oxidizing agents, we get acid. Right? Salicylic acid. Right? So they are asked primary alcohol to aldehyde. So mild oxidizing agent in these options. So they have given options like this. Option number A, A2Cr2O7, B, CrO3, C, BCC, and D, KMnO4. Here, we know that, we must know this, right? Strong oxidizing agent, KMnO4 is strong, A2Cr2O7 is also strong, CrO3 is also strong, but PCC, pyridinium, it is a mild oxidizing agent. So option number C is a correct option. Let's move on to next question. In the reaction, we have given us a reaction. Let's see reaction. What is the reaction here? Formation of here will have C6H5Cl reacted with SnCl2 plus HCl is the reagent used. HCl plus we get treated with concentrated POH, we get Y plus Z. Okay, which is the reaction undergone in the formation of X and the formation of Y. Okay. They have given us C6H5Cl in presence of SnCl2 and HCl plus HCl and H3O plus. And we have to find out what is X here and what is Y here. No, we are not supposed to find the product here. We have to find which type of reaction it is undergoing, like which type of neighbor reaction it is undergoing. So we know that this is a nitrile group, right? when nitrile reacted with this, if we look into this reagent, we know that it is undergoing this reaction, which is Stephan reaction, the Stephan reduction reaction. Stephan reaction. So in presence of H2O plus, we know that it is going to convert into C6H5 CHO, aldehyde. We get aldehyde here. When aldehyde reacted with concentrated KOH, we have, when we look into this concentrated KOH, where do we use concentrated KOH? Generally we use in one of the named reaction known as Cannizzaro reaction. But the condition for Cannizzaro reaction is when 2 molecules of C6H5CHO is taken here and we get the 2 products here. Okay. The condition for Cannizzaro reaction is it should not have alpha hydrogen. Does this compound has alpha hydrogen? C6H5, this is a ring, this is again a functional group, there is no alpha hydrogen. Then it reaction and finally we get a product. So here 2 reactions are happening, Stephan reaction and another one is Cannizzaro reaction. And if you look into the options given, they are given Wolff-Kishner reduction, Woods reaction. Option B, Stephan reaction, Cannizzaro reaction. Option C, Rosenman reduction, Cannizzaro reaction. And option D, Clemmensen reduction and Sandmeier's reaction. So option number B is the correct answer. We know that Stephan and Cannizzaro reaction is undergoing. Okay. So let's move on to the next question. Again, they have given one question that is from a mind chapter. Anyway, in the reaction is this. We have anything here. Aniline, we don't know what is the reagent taken here, but we have a product. We have the product that is N2Cl, N2Cl minus plus. Okay, and again Q we don't know what it is, and here we are getting a product N2BF4, and here R. Here we are getting R. We are getting NO2. Thus, find out P, Q, and R respectively. R. What are P, Q, and R? What is this? This is the aniline, right? Aniline is getting converted into benzene diazonium chloride, right? Here, what is undergoing? Obviously, diazo compound is got, then it is undergoing diazotization reaction. Diazotization reaction. And what is the reagent we usually use here? NaNO2 and HCl, right? So, if we want to eliminate the options, in the option itself we can eliminate, because in the 3 options they have given NaNO3 here, and only in one option they have given NaNO2. From there itself, no need of solving all the other, there itself you can choose the correct option. And again if we want to see, no problem, we'll solve further. Okay, here we got N2Cl and here N2, the chlorine is replaced by BF4 minus. Here we are using HBF4 as a reagent. In this way, you can eliminate the options and you can choose the correct option. So here the correct option is option number C, that is NaNO2 plus dilute HCl, HBF4 plus Cu and NaNO2. That is the correct option. Let's move on to the 8th question, that is from biomolecules. It's from biomolecules. Thyroxine produced in the thyroid gland is an iodinated derivative of thyroxine. Thyroxine is produced by a thyroid gland, right? This is a hormone which is produced by thyroid gland. And this is a derivative of what? This is a derivative of what? This is a derivative of thyroxine. So in the option they have given option number A tyrosine, B tryptophan, and C triazinine and lysine. So option number A is the correct option here. Tyrosine is the correct option. Let's move on to the next question, that is ninth question, that is also from molecules from a topic disaccharides. Disaccharides. Ninth question is from disaccharides. The question is like this: sucrose is dextrorotatory. After hydrolysis, the mixture show levorotatory. This is because of sucrose. We know that sucrose is a disaccharide, right? Which on hydrolysis we get glucose and fructose. These are two monosaccharides which are present in the sucrose, right? This is alpha glucose and this is beta fructose. Here, if we look into its optical activity, we know that glucose shows plus 52 degree rotation and this shows minus 92 degree rotation. Because of this, if we subtract these two values, overall, what is the value we are going to get? 92 minus 52, 0, 40, right? So minus 40 degree. So again, minus indicates it's a levorotatory. Therefore, sucrose shows a levorotatory, right? So in the option, if you see, they have given A racemic mixture is formed. Because racemic mixture is formed, no, it is not a racemic mixture. Option number B, levorotation of fructose is more than dextrorotation of glucose. True, right? Levorotatory rotation of fructose is more compared to dextrorotation of glucose. So option number B is here. Let's move on to the next question, that is 10th question. Let's see the next question, option 10th question. That is, they have given a two column here, X and Y. Okay, here they have given a vitamin A, B, E, K. Vitamin A, vitamin E, and vitamin K. Here they have given muscular weakness, night blindness. Sorry, here they have given night blindness, dementia. Okay. By looking into the question itself, we can solve that. Vitamin A shows night blindness. Deficiency in vitamin A shows night blindness. From there itself, you can remove the options and you can choose the correct option. That is option number B is the correct option.